Today we're going to talk about Workbook 3A, Exercise 11. In the textbook it's page 30 and 31. This is more subtraction problems, but for today I'm going to say for the most part you're going to do these vertically and go right to left, but I'll show you that if you want to do it a different way with addition instead, I'm going to remind you of that strategy. I'm not going to do all of the problems in the workbook. There's a lot of practice. The truth is you'll have plenty of practice as long as you know the steps and how to do them. You'll be fine. Number 6 on page 30 asks us to find the difference between 2,435 and 1,268. Always, 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 the book has beautiful pictures, shows you what you're doing. We don't ever want to forget what it is we're doing when you subtract and how it is that you're doing it. But the idea here is I have 5 ones and I have to take away 8 ones, but I don't have 8 ones to take away. So if I change the 3 tens to 2 tens and I make that extra set of tens into ones, now I have 15 ones, take away 8 ones. I like to think of taking the 8 out of the 10, that leaves me 2. 2 and 5 is 7, but however you think of 15, take away 8, it's 7. Now I have 2 tens, subtract 6 tens, can't do that either, so my hundreds become 310 tens. Now I have 12 tens, take away 6 10. The 6 comes out of the 10 and gives me 4. 4 and 2 is 6. 12 take away 6 is 6 tens. 3 hundreds take away 2 hundreds is 100. 2,000 take away 1,000 is 1,000. That's a perfectly good way to do it. I also like the idea of taking 1,268 and making it 2,000 by thinking about adding so that I have 7, I need 9 hundreds, so I add 7. I need 9 tens, so I add 3 tens, and I need 10 ones. And then from 2,000 to 2,435, that's 435, and then I have to do an addition problem. That's going to give me 1,167. Not surprisingly, I get the same answer. Either way works just fine. I don't think there's one way is a ton better than the other, so whatever you think. I'm just going to do 4 examples if you want to watch and remember a little bit more about how to do these. When I borrow from the 10 and get a 0, 13 take away 5 is 8. When I borrow from the hundreds, that'll become a 10. 10 take away 8 is 2 tens, and then I have 4. Don't forget 7,000 take away nothing is still 7,000. With the other way, I could make this into 200 by adding 15, and then to get to 7,613 I need 7,413. So not surprisingly, when I add those together, I get 7,428. Letter E, I don't think I said it, that was number 7 on page 30, that was letter A. Letter E is 6,094, subtract 4,028. I bet you can do the vertical. I'll do as an example just to make sure. That becomes 14 minus 8 is 6. 8 take away 2 is 6. We want to make sure we know if you have 0 take away 4, you have to borrow 1,000 to have 10 hundreds. So you have 6 hundreds left in 5,666. But again, if I want to go from 428 to 500, I can do that by adding 72. From 500 to 1,000, maybe we want to take one more step in there, is 500. And then to get from 1,000 to 6,094 is 5,094. Look at me. I wrote it without place value. 5,094. Having trouble writing today. There we go. So that would end up being 5,000. Notice you're going to have 600 when you combine the 500 and then the tens make another 100. And then of course you'll have 6 tens left over and 6 ones. Again, we're not shocked it's the same answer. It has to be the same answer, of course. But the idea is that you can do it a few ways, and you can go from 428 to 500, from 500 to 1,000, from 1,000 to 6,094. That works. The other two examples I chose were on page 31, 7,165 minus 5,268. We just get lots of practice changing a 10 to ones, changing 100 to tens, changing 1,000 to 10 hundreds. So in that problem, each one of those numbers had to be borrowed and carried, we call it. Notice from 268 to get to 6,000, I need 900, 9 tens, 10 ones, and then 1,165 will take me from 6,000 to 7,165. And if I add those, I'll have 1,000 and 800 and 9 tens and 7 ones. I do like that right side method, but it's also good to know how to subtract from borrowing and carrying. Last problem today, last example, 3 take away 2 is 1. I don't have enough tens, so I borrow from the hundreds. 15 tens take away 7 is 8 tens. Borrow from the thousands to get 12 hundreds, take away 5 hundreds is 7 hundreds. 7,000 take away 3,000 is 4,000. Again, taking this to the nearest thousand, I need 900, 9 tens, 10 ones. And then I'm going to have 4,353. And altogether I have 4,000 and not enough hundreds to change that. I have 7 hundreds and not enough tens to change that. I have 7 tens, but I have an extra 10 from the ones, and then I'll have 1 left over. So you have these examples. You can do exercise 11, and however you choose to do it is fine. I think for this level of problems, it is perfectly fine to stack them vertically and go right to left. But if this fascinates you, I think it's an easy way to think about it mathematically and get perfectly good answers.